Alright guys, welcome to this page of the notes, and what we're going to do is we're just going to get some practice now doing problems where we're going to perform transformations, right, on some sort of pre-image. Perform the transformation to get back the image, okay? Again, these are not too terribly tricky. Once you feel like you've kind of got the hang of it, please feel free to work ahead. Try the problems on your own. Just come back to check and see how you did, all right? So let's just jump right into these and run through them. Here we go. Given the points below, graph the pre-image. Let's do that first. Point A, point B, point C. Graph them, figure out what is your pre-image. I'll do that in red. A is at 0, 4. 0, 1, 2, 3, 4, right? It's always X comma Y, so there's A. 3, 0, so again, X, 3, 1, 2, 3, 0, right there. So there's A, B, and C is at 0, 0. Awesome. So here is my pre-image. It's a triangle right there, right? There's my pre-image. I just graphed the points that I was given. Now here's what they ask you to do. They want you to perform the transformation given to you here. I'll talk about that in a second. Perform the transformation and then graph the image. Where's the image, right? What do you get back after doing the transformation? And then finally, just describe that transformation. I said in the essential question, you need to be able to describe what's going on using words, right? The language of geometry. You got to be able to speak the language, write the language, read the language of geometry. We're going to practice that, okay? Okay, so here we go. I need to perform the transformation. Let's talk about that for a second. There are two different ways, and both are perfectly valid, and both are relatively easy. Let me show you. Two different ways of describing a transformation, all right? Here is one way of describing a transformation. Here is the other way of describing a transformation. This one we saw on the previous page, all right? So you know how this one works. Let me talk about this one for a second. It's saying the exact same thing. Please look at this. You are given the pre-image, xy, right? I have an x and a y, 0, 4. This is going to tell you, right, the transformation you're going to perform, right? You're going to subtract 4 from whatever the x value is. Plug the x value in, subtract 4, you're going to get out your pre-image coordinate. Same thing for y. You're going to subtract 3 from the y value, right? Get out your image coordinate, okay? It works the exact same way as this. Please notice, negative 4, negative 3. The a always goes with the x, so it would be x minus 4, right? It's just another way of writing this that we saw on the previous page. Hopefully you see that. Be comfortable with both ways. I will ask you to do it both ways, okay? So here we go. Let's do this. I am going to perform my transformation. So here we go. Let's do it. Transformation. A is going to be transformed this way. I take the x coordinate, which is 0, and I'm going to subtract 4 from it. This says the exact same thing. Subtract 4. So 0 minus 4, comma. I'm going to take the y, which is 4. These both say the exact same thing. Y minus 3, this says subtract 3 from the y value. They both say the exact same thing. Doesn't matter which one you use, okay? So this is my transformation. Subtract 4 from the x, subtract 3 from the y value. I'm going to get out, right, my image. Sorry, this is the pre-image. Pre-image, I perform the transformation, I get out the image. So this will be A prime. And what do I get? 0 minus 4? Minus 4. 4 minus 3 is going to be 1. So the pre-image, A, is going to be mapped, using the transformation, it will be mapped to negative 4, 1. So I'll plot that in just a second. Let's do the rest of them. B. My x is 3. Transformation says subtract 4. My y is 0. Transformation says subtract 3. Okay. B prime then. 3 minus 4, negative 1, 0, so minus 3. There we go. I have my pre-image B. I have my image B prime. I'll plot B prime in just a second. Let's do it for C. C is 0, I subtract 4. Y is 0, I subtract 3, right? That's what my transformation says to do. Subtract 4 from the x, subtract 3 from the y. Just follow the transformation, no problems. C prime, negative 4, negative 3. Here we go. Let me do these in a different color. I did my pre-image in red. Let me do this one in green. So A prime is going to be at negative 4, 1. 1, 2, 3, 4, 1. So right there, that's going to be A prime. B prime is going to be at negative 1. So I'm going to go to negative 1, negative 3. 1, 2, 3. So right there, that's B prime. C is now at negative 4, negative 3. 1, 2, 3, 4. 1, 2, 3. There's C prime. Okay, so here we go. Pre-image, I perform my transformation, I get my image. That's graphing it. That's exactly what I asked you to do. Given the points, graph the pre-image. Did it. Perform the transformation, graph the image. Done. Describe the transformation. Fantastic. Here we go. Please take a look at this. Describe the transformation, compare the pre-image to the image. Big deal. This is what we're going to do, all right? Again, I wouldn't expect you to know this. We'll go through a few and I think you'll get it. Please look at this. Notice a couple of things. I have a triangle. That's my pre-image. My image is also a triangle. Did I change the shape? No. No. And you take a look at it. Look at the size of the pre-image. Look at the size of the image. Did I change the size? No. So the shape is the same. The size is the same. Size is the same. What has changed? Its position. I moved it. So this is what's known as a translation. You should remember that from algebra. When we translated a function in algebra, we moved it left, moved it right, moved it up, moved it down. Right? We moved it around on the coordinate plane. A translation. A change in position is a translation. Okay? So, describe the transformation. We've done a translation. I have changed the position. You could even write change in position. Now, I would prefer, right, that you just say translation. Right? Change in position is a translation. They mean the same thing, and this is a more high school geometry way of saying we change the position. So please, whenever it's a change in position, please use translation. It's just a better way of saying it. Compare the pre-image to the image. Same size, same shape. Okay, super, super easy. Hopefully you've got the hang of these. Please feel free to work ahead. Come on back, check and see how you did. Let's keep going. We're just gonna plow right through these. Let's do this. Again, exact same directions. Let's just do it again. I'll graph my 3 points, do my translation, graph my image. We'll talk about it. R, negative 4, 3. So 1, 2, 3, 4, 1, 2, 3. Right there. That's R. Give me S, negative 1, 1, 2, 3. There's S. S. T, negative 4, 1, 1, 2, 3, 4, 1. There's T. Again, I've got myself a triangle. Okay, fantastic. So that's my pre-image. Let's do transformation. Okay, again, look at this. T, the transformation, says the exact same thing here. Guys, look, it says they both say the exact same thing. So it doesn't matter which one you use, be comfortable with both of them, all right? The X, right? Now you're looking at this, you're like, hang on a second, the last one had numbers there. Don't let that confuse you. This is actually even easier. Here's what it's telling you. Whatever the X value is, make a negative. Take X, make a negative. If it's already negative, negative times negative, it'll now be positive. If the X is positive, you make it negative and now it's negative. Look, the Y value, nothing. You didn't do anything to it. The Y value just stays the Y value. Check this out. Look at how easy this is. Oh my gosh, I love these. So I had R. I'm now going to perform my transformation, which says make X negative. So minus the minus 4. The Y value, don't do anything to it. It just stays the same. So what is R prime? Well, now R prime is minus 4. That's a positive 4. So we're now at 4, 3. That's it. Super, super easy. It doesn't have to be complicated. Please don't make it complicated. If it's simple, be happy it's simple and just keep going with it. So just make the x negative, y stays the same. Let's do s. Let's do s. It says negative x, so I'm going to do a negative of -1, that's my x. Y, don't do anything to it, it stays the same. So s prime is now at negative of a negative, 1, 3. That's it. It's just that simple. T. So I make the x negative, but it's already a -4. Okay, awesome. And then the y stays the same. So 1, so t prime then is going to be 4, 1. Great. Let's go ahead and graph these guys now. I did my transformation. Graph the image. 4, 3. 1, 2, 3, 4. 1, 2, 3. This is now r prime s. 1, 1, 2, 3. This is now s prime. 4, 1. This is now t prime. There is my triangle. Fantastic. Okay, great. So my preimage, my image, after doing the transformation. Now, very, very important. Finally, describe the transformation, all right? So here we go. In the last one, what we saw was we simply saw a change in position, just moved from one spot to another. Please notice, and again, this is the first time maybe that you're seeing it, so don't panic if you didn't see this right away, but after I show it to you, you'll recognize it. They're not that hard. If I were to go ahead and just put a little line right there, this is my pre-image. Consider this. If I were to take that yellow line and just spin it, if I were to give that yellow line just a little spinny, spinny spin, right? This would take my triangle, RST, and just flip it over onto R prime, S prime, and T prime. Do you see that? Right? See how if you just spin that y-axis, it'll just, guys, that's what we call a reflection. Shouldn't have to think about it too hard to quickly see, hey, these are mirror images of each other, right? If this were you standing in front of the mirror in the morning, right, what do you see? You see your reflection. You see yourself reversed in the mirror. Think of the y-axis as the mirror. This triangle is standing there looking into the mirror. What is it going to see? It is going to see its reflection in the mirror. The exact same object, just reflected, right? So that the orientation has changed, but please notice what is the same? The size and the shape. So far we have seen a translation, a change in position. Now we have seen a reflection, right? Where you're just simply reflecting it across the line, a mirror image. In both cases, the translation and the reflection, the mirror image, the size and the shape have stayed the same. All we've done is just change the position. This is also a change in position, but more specifically, right, it's a reflection, all right? Which is why we've got to use these more high school, more algebra terms, right? Because if you just said, oh, a change in position, okay, but specifically what kind of change in position? A reflection. It's a reflection, all right? Head on over to the next page here. We got a couple more for you, and again, these are really pretty simple. Wait, did I screw some? No, I didn't. Here's what we've got. Oh yeah. Oh, I love these. All right. Fantastic. Here's what we're going to do. In this one, what I've done is I've given you, right, I've given you the pre-image. Go ahead, figure out those coordinates. Super easy to do, worth the practice, good practice. We'll perform the transformation, right? Graph the image, no problemo. Here we go. Let's call this one right here, boom. That's going to be J. It's at 2, 2. Sweet. K, whatever, let's call that one K. Right there, we'll call that K. This is going to be at -1, +2, so -1, 2. Awesome. L, well, that leaves me this one down here. Again, it doesn't matter what order you name the points in. Please don't think if you did them in a different order that you're wrong. You're not. You're going to get the exact same thing that I am. You will. You've just named your points in a different order. Okay, not a problem. You'll get, your graph will look exactly the same as mine. It's just your vertices will be named differently. No problem. All right, that is okay. So we're going to be at 2, -4. Okay, now I've got my pre-image, do the transformation. So my transformation then is going to be 2 times the x value. So take the x value, multiply it by 2, and then keep the y the same, right? So really pretty easy. So j is going to be 2 times 2, keep the y value, which is 2. So j prime is going to be 4, 2. K, multiply 2 times the x value, -1, keep the y value. So k prime is going to be -2, 2. L, again, you should, right, these are not hard. You guys got this. You're a bunch of smarty pantses. 4, -4, right? So I just quickly, right, jot down my transformation based on, right, what these both say the exact same thing. Be comfortable with both of them. They say the same thing, right? Jot down your transformation and go ahead and get yourself your image, right? Plot it out. Let's graph it. 4, 2. I'll do it in green. 1, 2, 3, 4, 1, 2. This is now j prime. K, -2, 2. 1. Sorry, I'm so sorry. Holy jeez. Listen, don't let me do stupid stuff like that, alright? Stop me when I do dumb stuff. 1, 2, 3, 4, 1, 2. There's j prime. X first, then y. +4, not -4, so sorry. K prime. -2, 2. Alright, great. So there's k prime. And then 1, 2, 3, 4. -4. L prime. Awesome. Okay, so now describe the transformation. I have the pre-image I was given, red. The final image after doing the transformation is the one in green. Hopefully what you can see by looking at this is that I have not changed position. What has happened? It's gotten bigger. So this is what we call, as far as transformations go, this is what we call a dilation. Dilation means a change in size. Could be a change in size for the bigger, like we have, or a change in size for the smaller, right? Either way, dilation could be for both enlarging or shrinking the size of an object. So we have done that. We've also changed the proportions of it, right? So the shape has changed in as well. So compare the image to the pre-image. Our image is larger. I don't know why I put a comma in there. Listen, I told you guys, my spelling and grammar are awful. Image is larger than the pre-image. I'm working on it though. I'm working on my spelling and grammar. I want to be good at it, but I struggle sometimes. Okay, hey, let's try another one. All right, run through this one super quick. I know you guys know how to do this, so we're not going to waste a ton of time here. Boom, let's just knock these things out. P prime. Please notice, P prime, this is the image. I'm asking you to find the pre-image, wherever that's at. Whatever, doesn't matter, works the same way. You're good. So P prime is at +1, 2, 3, 4. So 1, 4. 1, 4. Q prime, let's call this Q prime. Okay. What you label the vertices, it doesn't matter. 1, -3, 1, and R prime. Again, so just the primes simply tell you, hey, this is the image. I'm asking you to work backwards to the pre-image. But none of that doesn't matter. You're still going to perform the transformation just like you would in any other event, right? So I've given you the transformation, so now we do it. So we're going to do P prime is transformed by leaving the x the way it is. So 1, make the y negative, so -4. Which means that P, not P prime, P is now going to be 1 -4. Q prime, perform the transformation. Leave x the way it is, -3. Make the y negative, so minus my y is a 1, which means that now, I almost wrote p again, sorry about that. Q is now 3 minus 1, and r, perform the transformation. X stays what it was, make the y negative. R, 3 minus 1. Okay, I'll do it in green. 1, 4, 1, 2, 3, 4, that's P. -3, 1, -3 minus 1, there's Q. 3 minus 1, there's R. I recognize this. Do you recognize it? Take that x-axis. Take that x-axis and just give it a little spinny spin spin. Spin, spin, spinny spin spin. And what would happen is that triangle, that pre-image would just right onto my image, right? It's a reflection. Good. Okay, compare the pre-image to the image. Again, what you guys can see, right? Same size, same shape. Same size, same shape. Not like the one above, right? Where you clearly change the size, maybe even the shape, because the proportions, they're not the same shape triangle. They're both triangles, but they're just different triangles. Same triangle, same size, same shape, all that's the same. Same size, same shape. All right, guys, hopefully that makes a lot of sense here when it comes to transformations and you feel really, really comfortable with it. Head on over to the next page of notes and we'll start to talk about rigid versus non-rigid transformations. I'll meet you guys there.